Okay, Assalamualaikum. Today we're going to start our class with three-phase AC circuit. Okay, it's a continuation from the previous slide. So in the previous slide, you have learned about the three-phase system. Okay, so I have shown you, okay, the supply side, okay, the transmission side, and also the load side. And I also have shown you the phasor diagram, if you still remember the phasor diagram. Okay, so this is the example of the phasor diagram of a three-phase system. So we are saying that EAO is actually the supply. Okay, also we can write it as VA if you want, okay, for phase A, and this is for phase B and also phase C. Okay, as you are aware, okay, our three-phase, okay, is actually a balanced three-phase, right? So that's why, okay, each of the phase is 120 degree displaced between each other. Okay, so why is 120 degrees? Because, okay, the full circle is 360 degrees divided by 3 because they are equal. So that's why it's 120 degrees. Okay, so in the three-phase system, there's a sequence. Okay, we say that ABC as a positive sequence. Okay, so we have two sequence. First sequence, okay, called leads, and the second sequence called lag. Okay, so that's what we're gonna have a look. Okay, so we have the first sequence called lag, and then the second sequence called lead. Okay, and you're aware is 120 degrees displaced between each other. Okay, because it's the balance load. Okay, right. So let's take, okay, example of lag first. Okay, so for the lag, okay, it's always clockwise action. Okay, so it's negative. All right, so in this direction, okay, you will say that, okay, you take EA as a reference. Okay, why EA is the reference? Okay, any voltage that actually starts with 0 degree is always a reference. Okay, any voltage that is 0 degree is always a reference. Okay, all right. So in this method, I'm going to say EBO is VB, EAO is known as VA, and also ECO as VC. Okay, all right. So you're already familiar, right? The previous video I already showed you the three-phase sine wave. Okay, this is VA, then that is VB, and that is VC. Okay, that is a voltage. Okay, right. So in this part is the same. Okay, we have VA, VB, and also VC, and they are 120 degrees displaced. So in this part, because it's lag, so you will say that, okay, taking VA as the reference, you will say that VB lags VA by 120 degrees. Okay, so the arrow is negative 120 degrees. Okay, and then now, okay, you will see that taking VA as the reference, okay, still, so now you say that VC lags VB by 120 degrees. Okay, so that is for lag. Okay, let's have a look at lead. Okay, so again we are saying that VEAO is VA, EBO is VB, and then ECO is VC. Okay, so for the lead, now it's going to be in this direction plus 120. It's anti-clockwise. Okay, so again, because VA is at 0 degree, so we take this as our reference. Okay, right. So now, okay, VA is the reference. So we are saying that VA leads VB by 120 degrees. So this plus 100. So VA leads VB by 120 degrees. Okay. And then saying that plus 120 degrees. So in here you're saying that VB now leads VC by 120 degrees. Okay, basically that is the lead and lag. It's very important for you to understand, okay, the difference between lag and also lead. And you have to understand they are always 120 degree displaced between each of the phase. And then you have to be careful of the arrow. Okay, so whether it's anti-clockwise or clockwise, so it depends on how you define it, whether lag or lead. And always from your reference, and the reference is always 0 degree, so you have to remember that. Okay, so from the previous examples, we have seen this diagram before, schematic diagram. So this part here is the supply, if you still remember from the previous video, and this side here is your transmission side, and here is your load side. Okay, so if you see here, this circuit, if you see here, this circuit is the simplification of this schematic. All right, so this is just this part, without the load. So if this is without the load, so this is just this part I translated into this more simplified diagram. Okay, so if you have a look, we have EO here, EO for phase A, ZD, and VAO. Okay, what is VAO? VO means, the voltage here, voltage phase A connected to common point O. Okay, that is VAO. So VBO is voltage V, VBO is voltage phase V connected to O. VCO is voltage phase C connected to O. So that is VCO. Okay, right. So if you see here, the ZD is the same, ZD for each of the phase, ZD. And then each of the phase is EA0, EB0, and EC0. Okay, all right. So if you apply KVL, then you will be able to derive this whole set of equation. Okay, so I'm going to do example just for phase A, as a revision, if you still remember. Okay, so we take EA node plus, this is the directions of IAN, Okay, so IAN times by ZD, okay, plus VAO equals to 0. So you reshuffle the equations, you will get EA0 minus IAN ZD. So that is for phase A. Alright, so you do for phase B and also phase C, and you will get this whole equation here. Okay, alright. Okay, right. So now, okay, so this is the simplified, okay, circuit of this circuit. Okay, so just now we didn't consider the load. So now in this phase, in this simplified schematic diagram, we are considering the load. Okay, so if you see here, okay, so now we are taking load, okay, the supply and also the transmission in the next diagram. Okay, right. So now you see the simplified for the whole system. Okay, all right. So now you see that, okay, since O and N, okay, this is O and N are connected at the same point. Okay, why they are the same point? If you extend the point, you see that they are connected at the ground. Okay, so if I extend, they're all connected at the ground. So that's why we can say that they are connected at the common same potential, neutral, same point. Okay, all right. So you have seen that previously the load side. Okay, so the load side, we are assuming, okay, you have ZR, that's your ZR, connected to this the N. Okay, so this is your VAN. Okay, all right. So VAN is this point. Because the point A, voltage at point A connect to the voltage point N. Okay, so from here, you can calculate your VAN as, okay, if you take this as your IAN, you will get IAN ZR, right? Okay, then you calculate the same for voltage. This is for phase A, but you can calculate for voltage phase B. So phase B is the same. Okay, you get VBN equals to IBN ZR. So for phase C is the same, ICN ZR. Okay, so that is for the load side. For the supply side, okay, the supply side, remember, okay, now we have VAO. A connected with, so we get VAO. Okay, so remember, VAO is EA not minus IAN ZD for phase A, and phase B is EABO minus IBN ZD. For VC is, phase C is ECO minus ICN ZD. So that is for the supply, and this is for the load. Okay, right. So based on, okay, what we say here just now, okay, O and N are the same potential. Okay, so O and N now is the same potential. So that's why we can say that VAO equals to VAN. So now VAN equals to VAO. Okay, so in that case, okay, let's change the color to green. Okay, so when VAN now equals to VAO, and VBN equals to VCO, and VCN equals to VCO. Okay, so based on this, you get this whole lot of equation. Okay, all right. Okay, so based on, so if we continue on, okay, so we say that VAN equals to VAO, VBN equals to VO, and VCN equals to VCO. Okay, so that's why, that's how we get this whole equation here. And we rearrange, okay, so if we rearrange this equation, you will get that IAN. Okay, so you can try to do it at your own time and rearrange this. Okay, sorry, you can rearrange and you will get this. Okay, IAN equation. Try it at your own time. Okay, so here's the summary what we have just learned. Okay, all right, so the next slide, okay, in this slide, what I want to mention to you, okay, what I want to emphasize in this slide is VAN. Okay, so far we have been taking VAN as the reference, but it's not always VAN as the reference. Okay, the reference means okay, the reference means the one that start with 0 degree. So means that, okay, VBN can also be the reference. VCN can also be the reference if it at 0 degree. So means that it's not always VAN as the reference. It can be VCN if it's at 0 degree. Okay, so you have to note that. Okay, all this while, okay, I have shown you the voltage. Okay, this part is very important. Okay, this is VA. VB. This is VC. So if you have a look, okay, here there's a Vmax. Okay, so what it means that the peak for each, the peak, okay, for VA, the peak for VB, and the peak for VC is all at Vmax. Okay, so they all share the same peak, VAB, VC, and VB. Okay, all share the same peak called Vmax. So that's why. And they are 120 degrees. Okay, so this is negative 120 because it's here. It starts from 0. So this is 240 because it starts from 0. You start the count from 0. Okay, alright. So now for current is also the same. Okay, you have 3-phase current and you label it as IA. And then you have phase B, that is IB. And then you have IC, of course. Okay, alright. And then if you see here, okay, they have a displacement angle. Okay, so displacement angle, okay, it means that they are not the same phase as VA and IA. So means that, okay, the IA is a bit displaced, so that's why we have a displacement angle of negative theta. Okay, all right, so let's have a look. You will see that clearer in the phasor diagram. Okay, later I will show you. Okay, so now you see that the current, okay, also shares the same peak, so I max. So this is I max. So IA, IB, IC also shares the same I max. Okay, and again they are negative 120 and negative 240, of course, because it starts here 20 and 240 from 0. Yeah, okay, so far you have you have learned all this, and then now we want to move to a phasor representation. We're going to have a look, okay, how you draw the phasor diagram for the voltage and also for the current. Okay, so we are taking, okay, the lag as an example. So if you see here, okay, you see here VAN is a reference. Why VAN is the reference? Because it's at 0 degree. Okay, and then you can see VBN is negative 120 displaced and negative 240. So when you see a negative, automatically it's lag. All right, so we're gonna draw VAN for now. Okay, so it's 0 degree, so that's why this is a reference. Okay, all right, so that is negative 120. Okay, that is for VBN, and then for VCN, from 0, yeah, so that is 240 degree, so that's why. Okay, okay, so now we want to draw IAN. So if you see here IAN here, okay, IAN now, okay, you see that we have a displacement angle of negative theta. Okay, so it doesn't start with 0, but it starts with theta. Okay, all right, so in this part, okay, all right, let's draw the SIAN. Okay, so this is the theta, because it's a lag, so that's why it's negative. Okay, all right, and that is for IAN. So let's draw for IBN. Okay, so IBN is the purple. So if you see here now, we have negative 20 and you have negative theta. All right, so negative theta, so negative theta is from VBN. All right, but negative 120 is this one. Okay, all right, so that is IBN. Okay, so let's go for this color. Okay, let's draw for ICN. So now it's negative 240, negative theta. So that is ICN. Okay, so it's gonna be negative 240 and theta. Okay, all right. and then negative 240 from IAN all the way. Okay, all right. Okay, so that is the phasor diagram. Okay, for voltage and current. Okay, you have to know that this representation is called phasor diagram. Okay, all of this is called phasor diagram. Have to know that name. Okay, all right. So that's this is going to be the last slide. Okay, so for the total power delivered in the three-phase load, okay, you have to understand, because we have three phase now, you have to calculate the power for each of the phase A, phase B, and phase C. All right, so in order to calculate the power, remember the power formula, V times by I. Okay, so you derive that, okay, after you simplify this long equation here, and you will get this final final equation. Okay, all right, the final equations, okay, this the simplified one, okay, 3 times by the magnitude of the voltage and also the magnitude of the current times by the cos theta. Okay, so this is the formula that you have to remember. Okay, it's not given in the exam, so you have to remember this formula. Okay, all right.